Okay, today we will start differentiation. This is like a basic mathematics required for doing physics.
Yes.
You already know a little bit about differentiation.
Differentiation. I don't really understand much about it.
Okay,
I don't know much. Nothing basically.
Okay, let us consider a function. Say y equal to f of x. So this is the function y equal to f of x. You know what's a function, right?
Yes, sir.
What is a function?
A function is basically something that say a function of x is basically a value which is dependent on x. So say if x increases, sometimes maybe f of x will decrease, or sometimes f of x will increase.
You can say it's a mapping from x to y, right?
Yes.
Okay, so it's a relation between x and y. Okay, so in xy plane, you can plot that function as a graph. So this is f of x. So here you can see as the x is changing, y is also changing, right?
Yes, sir.
For example, these 2 points, x is changing from what to what? x1 to x2.
Yes.
And similarly, y is changing from y1 to y2. Okay, so when x is changing by this much, how much is y is changing? That relationship is called derivative. Function you can think as a system in which input is x and output is y. Okay,
Yes,
now suppose I increase the input by a small amount delta x, how much does y change? So the change in y is delta y. Okay, so delta y by delta x, this interval delta x of the input increment, I can make it very, very small. Okay, so in the limit, when delta x tends to 0, delta x tending to 0, the meaning is delta x is very, very small. If someone says delta x is minus 1000, you can
the
say
delta is something like really. Oh yeah, never mind. Said it.
delta is a little bit bigger element.
Yes, sir.
You can say finite interval. Okay, so when the finite interval becomes very, very small, it's tending to 0, then it becomes an infinitesimal element.
Yes, sir.
Infinitesimal element. That is called dx. We need to say a symbol called dx. So delta x in the limit, delta x tending to 0 will become dy by dx. Delta y by delta x in the limit delta x tending to 0 will become dy by dx. And this is called derivative of y with respect to x. So it basically gives the idea of how y is changing when x is changing. Right?
Yes, sir.
Okay. Now,
So the basic meaning of derivative is basically like function of x and y, right? Function of x and x, right?
basic meaning of derivative is how fast the output is changing when you change the
Yeah. So basically, how the other value is dependent on another value. Basically that.
No, that is f equal to y equal to f of x. This is
In derivative.
how fast the output changes, y changes when I change x by small amount. When I'm changing x by small amount, how fast the y is changing? Suppose if delta x is 1, is delta y 100, 1000, 0.1?
Okay, that way. So that's derivative.
Yeah.
So say y is faster. Never mind.
Yeah, we'll get to that. Hold on, we're just starting. Okay, so this is that curve, y equal to f of x. Okay, so these 2 points which have been chosen, 0.1 and 0.2, right? So between these 2 points, delta y is this distance, right? This idea of coordinate geometry. Delta y will be this vertical distance.
Yes.
The 2 points 1 and 2. Delta, and similar delta x will be the horizontal distance. Yes.
Yes, sir.
So if this angle is theta, the angle, and if I join these 2 points 1 and 2 with a line, that line is called what?
So where's point 1 and 2? I can't see.
This is point 1.
Oh,
This is
okay.
point 2. Okay.
That's the radius.
If you join these 2 points by this line, okay, it's called chord or secant. In a circle, you know a chord, right? A line
Yes, sir.
segment touching 2 points. Similarly, this is a curve in which a line segment is touching 2 points. Okay, it is called chord or a secant.
Secant.
Yeah, you can call either of them. So it forms a triangle, right? And
Yes, sir.
that triangle is this one with the vertical distance as delta y, horizontal distance as delta x, and this is the secant or the chord which is joining these 2 points, 1 and 2. So what is tan theta now?
Tan theta will be delta y by delta x.
Yeah, okay. And right. So how fast that delta y changing with respect to delta x is given by this tan theta. Now if I bring this point 2 closer to 1, okay, that way delta x will keep on decreasing, right?
That way delta x will decrease. Yes, sir.
So in the limit when delta x tends 0, the
Oh, wait,
secant
sir.
will,
Sir, if you bring it if you bring it closer, even delta y will also change.
yeah.
Oh
Because
wait, yeah, that's derivative. Yeah, that's the derivative.
delta x is understood as an independent variable. Okay, so when point 2 approaches point 1, delta x will keep on decreasing. So in the limit when delta x tends to 0, when it becomes very, very small, the secant will almost become a tangent. What is a tangent?
A tangent is a line which passes through the circle at just one point.
It can be for a curve also.
It only passes or intersects with that curve at one point, right?
You cannot say intersect, say touches.
Touches.
Okay, so that's a tangent. So when delta x becomes to 0, tends to 0, uh, this secant will become a tangent. Okay,
Yes.
and the picture will look like this now. This dy and dx are very, very small. Okay, just for the sake of understanding, I've enlarged it. So again, tan theta is dy by dx, and this dy by dx is called derivative of y with respect to x.
So
Okay,
derivative is basically tan theta.
yes. Say dy by dx are at that particular point, this you have to get tan theta at that point because theta is going to change from point to point. At this point,
Yes, sir.
at this point, so the tangent is different, and those two tangents have different theta.
Yes.
So this is the basic idea of derivative. Right. This is the curve. So the 2 points are there. At point 1, if I draw a tangent, if this is tangent 1. So whatever that angle that the chord is making uh, with this horizontal is the same. Delta x is horizontal, no? Delta y is vertical. So the secant or chord, the angle which it makes with the horizontal is same as the angle which it makes with the x-axis because x-axis is parallel to delta x.
Yes, sir.
Okay. So at point 1, if you want to get that angle theta which the tangent makes, I just have to extend the tangent and see how much angle it makes to the x-axis. Okay, so at point 2, the tangent makes an angle theta to the x-axis. So dy by dx, that is derivative of the function at point 1, that is represented by this symbol, dy by dx, vertical bar at point 1. Okay, is equal to tan theta 1. Where theta means dy by dx is derivative, no?
so
Derivative is,
tangent forms at point 1. I don't understand how you got it from what you did with point 2, sir.
Why do you have a different tangent? No,
Yes. Oh, okay. So the angle between tangent of point 2 and tangent of point 1.
angle is always with the positive x-axis.
Yes, sir.
Don't. What are you doing with the keyboard? You're playing.
No, sir, I'm not doing anything.
Some noise is coming. Okay, so at
Probably
point
the
two.
pen clicking.
Okay, at point two the tangent is different, so it's making a different angle theta two with the x-axis. So dy by dx at point two is tan theta two. Okay, so the basic thing is dy by dx, that the derivative it changes from point to point because the tangents are different.
Yes.
So the important thing is the dy by dx is a function of x. Okay, and I can call that function as g. It's a function, right? I can use any letter to represent a function like y to
Yes,
x of
sir.
x. So I can use g. But instead of writing g, because this thing is got from f, right? Instead of writing a new symbol g, I just introduce f dash. The dash represents the derivative. So in some sense, f dash x equal to d by dx of y, which is f of x in this case. D by dx of f of x is a function. I can represent a g of x. So
So I didn't understand. So d by dx fx.
of fx.
Oh, okay. Of fx. Okay.
It is same as dy by dx. Instead of y could f of x, no?
Yes, sir.
That's what I've written here. So it is when x changes by dx, how much is d of f of x is changing? That is d of f of x. So this function, instead of using another symbol g, I'm just using f dash, just to denote that f dash comes from f.
Yes, sir.
Now this is another function f of x, which is a straight line. Okay. Now here I'm putting 2 points, 1 and 2. So what is f dash at x1? It is slope of the tangent at point 1, right?
So is it a straight line?
Yes.
Okay. So, sir, what did you say again? Sir, I didn't get your question.
F dash x is slope of the tangent, right? That
Yes,
is,
sir.
that is the interpretation, right? d over
So,
x
but if it is a straight line, then shouldn't the tangent be equal to the slope of the line?
yes. So f dash at x1 is tan theta, and f dash is x2 is also tan theta. So it is constant from point to point.
Yes, sir.
So f dash x, where f of x is line, it's a constant. Okay, for all x. Because for in a straight line, the slope is not going to change from point to point. That is the property of straight line. To understand,
Yes, sir.
if you draw a tangent, the tangent is same as a line, and is the same line for all the points. So all the points make the same angle theta. The tangent at all the points make the same angle theta with the x-axis. So d over x is same at all. Does not change from x to x. One point to another point.
So if that's the case, then what will be the derivative of this?
Constant. It's not a function of
Just
x.
any. Oh, so any constant? Just any constant?
No, it will be the slope of the line. See,
Oh, okay.
this line has got this much theta. There will be another line which is say steeper. This will have a different angle theta too. So d over dx of this line and this line are different.
But
That's
if you
what
have a curve,
curve
if you
is
have a
different.
curve,
Curve is different.
then it'll be different.
Let's just finish straight line first. So straight line, the derivative will change when the slope changes.
Yes, sure.
Okay, now here is the curve. For example, let us take one particular example, y equal to x square. Okay, y equal to
Okay,
x square
sure.
will pass through origin. Why will it pass through origin?
Pass through origin. So because the square root of x can also see. So no, yes. So we can also write because in this case the range will be minus infinity to plus infinity. So you
No,
can go.
the question I asked is different. It passes through origin, right? How do you know that?
So because if we take, so because 0 into 0 is 0.
If you put x equal to 0, you get y equal to 0.
Yes, sir.
So 0 comma 0 is a point on the curve.
Yes, sir.
So that is the origin. So the curve will pass through the origin.
Yes.
Okay. So I'm taking 2 points 1 and 2. The slope at which point is more?
At which point the slope is more
1 and 2.
at point 2.
Yeah. So dy by dx at point 1, let me call it theta 1, tan theta 1, and at point 2 is tan theta 2. Okay. This is because the angle of the tangent changes. So dy by dx, the definition is limit delta x to 0, delta over delta x, right? This is the definition
Yes,
of
sir.
derivative. There is nothing to think about it. It's just the definition. And delta is y2 minus y1. Delta is change in y, y from 1 to 2, right?
Yes, sir.
Uh, delta x is x2 minus x1.
X2
Minus
delta. So
delta
can you
x.
repeat?
Delta x. Delta x
Yes,
is
sir.
x2 minus
Is
x1.
x2 minus x1. Yes, sir.
And y2 is x2 square. Because
Y2.
the curve is y equal to x square, right?
Sir, you're speaking really quickly. It's hard to track.
Y2 is x2 square.
Y2 is x. Yes, sir.
Because the curve of the equation of the curve is y equal to x square. So put
Yes, sir.
any value of x, you'll get the corresponding value of y. Okay. So at point 2, the value of x is x2. So y2 should be x2 square.
Yes, sir.
Similarly, y1 is what?
Y1 is x1 square.
So that's what I've written for y1 and y2 divided by x2 minus x1.
Yes, sir.
Okay. So and x2 I can write as x plus h. X1 I'll take it as ax and x2 as x plus h.
So what's h?
Okay.
So what's h?
H is the
H.
difference between x2 and x1. See, these 2 points are coordinates are x1 and
Oh,
x2, right? So that I can take coordinates like x comma y and x plus h comma say y plus k.
yes, sir.
No problem, right? So I'm using that one. So x2 is x plus h whole square minus x square divided by x2 minus x1 is h. Right?
Yes, sir.
So from this, how do you get this one?
But I didn't. Yeah, I didn't understand that.
So
No,
after
it's
that,
a, can you sir, can you repeat the previous step? I didn't understand.
this step is okay, right? This one.
No, sir, can you repeat the previous step? How you got x square minus x1 square by x square? Oh yeah, I got that. I got that. Okay. No, so I didn't understand how you got x plus h square
X2 is what? X plus h.
and x1 will be.
X.
So no, still don't understand.
What you didn't understand?
So how'd you get x plus h square?
That's what I'm saying. The points are taken 1 and 2, right? So point 1 I can take it as x1 y1. Instead of that I can take it as x and y. It's a general point, a moving point. Okay. And point 2 I can take it as x plus h, comma y plus k. Two points I can take as x comma y and then x plus h comma y plus k.
So what? Oh yes, sir. Yes, you can.
Uh, okay. So using that for x1 and x2, you get this one.
I'm not understanding.
You're not listening properly. You're just substituting x2 as x plus h, x1 as x. That's it.
I didn't. Okay, I got it, sir. Got
Yeah,
it, sir.
you're not listening properly.
I am.
Okay, from this you can get this one.
Yes, sir.
A plus b whole square. So x square will cancel with x square. 2xh plus h square. Okay, and h2 can cancel. If h is exactly 0, you cannot cancel. But here h is tending to 0. When delta x tending to 0 is same as h tending to 0.
Yes, sir.
Because delta is the difference between x1 and x2, right? Delta x tending to 0 is equivalent to h tending to 0. And the limit is delta x tending to 0, that is same as saying h tending to 0. So h and h can cancel because h is not exactly 0, it is tending to 0. And this will become h. So when you put h equal to 0, tending to 0, it will become just 2x.
So 2x plus h is the.
H is tending to 0, right?
H is turning to 0.
It will be like 10
Here,
to, it will be 10 to minus
yeah.
1000. 10 to minus 10,000. So in the limit it is 0.
It's a very, yes.
This is standard technique. From that you get an important result which I have marked in yellow here. D by dx of x square is 2x.
So d by dx of x square is equal to 2h. Yes, sir.
So here the derivative is changing from point to point because x is
But sir, you're also dividing it by 0, right?
it's tending to 0.
So
It's tending to 0, it's not 0. That's the big difference.
Oh, okay.
That's why you can cancel. 0 by 0 is indeterminate, but h by h is determinate. H by h is 1. 0 by 0 is not defined. Okay, so here you have d by dx of straight line is constant, which is equal to the slope of the line. Here dy by dx is d by dx of x square is 2x. It's a function of x, not a constant.
Yes, sir.
Now the next higher level is you take this function y equal to x raised to the power n. Okay, now we have to find derivative of this curve or the function.
So what's the function here?
X raised to the power n.
So it can be to any power.
Yeah, here n is 2. I'm generalizing now. Okay, this is general n, not just 2. So in that case, again the understanding of derivative is limit h tending to 0 y of x plus h minus y of x divided by h. Is basically delta x, delta y by delta x, no? The 2 points are x and x plus h. Same thing, x and x plus h and y and x, y and x plus h, y plus b. So the change in the two x values are x plus h and x, and y values are y plus k and y. Okay.
Yes, sir.
So y2 is y of x plus h, and y1 is y of x divided by x2 minus x1 is h. And y, if you write in terms of x, will be x plus h raised to the power n minus x raised to the power n, because the curve is y equal to x raised to the power n.
Yes.
Divided by h. Okay. Right. Now we have to use one important identity, which I marked in yellow in the right side. A raised to the power minus b raised to the power n is a minus b into a raised to the power n minus 1 plus a raised to the power n minus 1 into b plus so on b raised to the n minus 1. Okay. This is just accepted. In higher classes, you will understand why this is true. Okay. So basically, a raised to the power is nth order sort of polynomial, right? Nth degree, you can say.
Yes, sir.
So on the right hand side, you have the first degree in a minus b, and n minus 1 should come from the rest.
Okay.
Okay, so the rest of the things will have a degree of n minus 1. So the first term is a raised to the n minus 1. The second term is reduce the power of n by 1 and increase the power of b by 1. So first term has b raised to the power 0, so it is going to be raised to the power 1. So the next one will be a raised to the power n minus 3 b square. so on, A will completely vanish and will become B raised to the power n minus 1. Last but one term is uh, uh, A into B raised to the power n minus 2. Right? So the total degree of the second factor will be n minus 1. The first factor is 1, the second factor will be n minus 1. So using this identity, you can write like this. A is x plus h and B is x. So denominator h is there. So A minus B is h in this case. That h will cancel this from denominator. Okay, and this will be a polynomial degree n minus 1. Okay, so here in the limit when you put h equal to 0, all of them will become x raised to the power n minus 1. And how many terms are there? Here b starts with 0 and goes up to n minus 1, so n terms are there. So you'll get n
Yes.
times x raised to the power n minus 1. So this is the result in the blue here. Derivative of x raised to the power n is n into x raised to the power n minus 1. Okay.
Yes, sir.
So the way to remember this result is the power n comes out and multiplies, and the power goes down by 1.
Yes.
So the same thing you can apply for x square. 2 will come out as 2, and power of x will reduce by 1.
Okay. So if I have anything if I have to find the derivative for any x to the power of whatever, I just take it out and then reduce the power by 1.
X raised to the power 5 is 5 into x raised to the power 4. Derivative of
Yes.
x raised to the power 7 is 7 into x raised to the power 6.
Yes, sir. And so what would it be if it was square root x?
Half, no, x raised to the power half. So it will become half into x raised to the power minus half.
So is there any? So what would be the generic rule if it was equal to square root or square root or cube root by any
Just now I said.
value? I didn't understand.
You're not listening, no? Half into x raised to the power minus half. Same thing you can apply.
Oh, okay. So I take it and then reduce the power by 1.
Yeah.
Okay.
Now you take this function y equal to sin x. Okay, I want to find the derivative of this function. Can you try in a piece of paper?
Okay, sir. Derivative of sine x.
You have to use a basic.
Yes, sir, I'm doing. So I have to do. So I just replace it like as if it's sine x plus h minus sine x, right?
Yeah.
And then by h, and then I have to use sine a plus b formula.
Sin c minus sin d.
So what's the formula for sine c minus sine
I've
d?
written here on the right side. The blue one. Sin c minus
Oh, okay. So it's very hard to read.
2 cos c plus d by 2, and then sin c minus d by 2.
Okay, I can't read it, so it's very messy.
2 cos c plus d by 2. The first factor. Second factor is sin c minus d by 2.
2 cos c by c plus 2.
C plus d by 2.
Oh, okay.
And then sin c minus d by 2.
C plus D by 2 into sine C minus D by 2.
Yes.
So into, right? C plus D by 2 into C minus.
Yeah. Left hand side is in terms of terms. Right hand side is factors.
So I consider two x plus h as C and x as D.
Yes.
So I get 2 cos into 2x plus h by 2 into sine h by 2.
Yes.
So how did oh wait, yeah, so it can be x plus h by 2.
And you have to use one more result, which I have written in the top, blue one. Limit h tending to 0 of sin h by h is 1. Use that result.
Which
The top one.
so h is turning into 0, or no, sine h by n is 1.
H, not n, h.
Oh, okay, sine h by h is 1. Okay. Sir, how will that help?
Yeah, I have written it down. See the step. Sin h by 2, and then remember h is there, and then 1, 2 is sitting there. So bring that 2 down, it will become sin h by 2 by h by 2. Here the limit h is tending to 0. So sin h by 2 by h by 2 is 1.
So I didn't understand how you use sine x. I listened, but I still didn't understand.
Sin h by h in the limit h tending to 0 is 1, right? That is the formula. Okay.
Yes, sir.
Instead of h, I can have h1. Just change of variables. Okay. My h1 is h by 2.
Yes,
Sine
sir.
of any quantity divided by the same quantity. When that quantity tends to 0, it is 1. So here I have sin h1 by h1 in the limit h1 tending to 0. h1 tends to 0 because h tends to 0. h1 is h by 2. When h is tending to 0, that very small quantity divided by 2 is also tending to 0.
Yes, sir.
That's why sin h by 2 divided by h by 2 is tending to 1.
Oh, okay.
Okay. The right answer will become just cos x plus h by 2. And that you put h tending to 0, it will become cos x.
Oh, okay, sir.
So here
So
you
then
get
don't have to use sine a plus b.
no.
Or should I
Actually,
just leave it?
no.
Or leave it the way?
Actually, that sin c minus sin d formula comes from this one, sin a plus b formula. That I told you in the maths,
Okay, okay.
in the maths class I told you.
Yes.
Okay, so you got the result that derivative of sin x is cos x.
Yes, sir.
Okay, now we can draw the graph of sin x. and understand why that is true. So the top curve is sine x, no? Sine 0 is 0.
So that ways, does it mean that the derivative of cos x would also be sin x, or not necessarily?
We'll come to the next. First finish this one. Okay. So sine curve is like this, no? The top one.
Yes, sir.
Sine 0 is 0, sine 90 is 1, sine 180 is 0. Okay. And cos curve, it will look like this. Sine cos 0 is 1, cos 90 is 0, right? And the relation between these two is this bottom curve's derivative of the top curve. That you can check at x equal to 0, the sine curve, if you draw the tangent, it looks like a 45-degree line. And in fact, it's 45-degree line, so the slope is 1. When sine x becomes 1 at the topmost point, the tangent is horizontal, right?
Yes.
This topmost point, uh, the tangent is horizontal. So at that point, the slope is 0. So cos is 0. And cos is also 0. So it's related. So derivative of sine is cos. And here in this part, the slope is negative. That is why the derivative is negative. Here in this part, the slope is positive. That's why the derivative is positive. So everything is
Yes,
consistent.
sir.
Derivative of sine x is cos x, right? Next, you will take cos x, derivative of cos x. Okay. The cos x curve is like this. Just now we saw in the previous one, right? And sine x curve
Yes.
is like this. But uh, derivative of cos x is not exactly sine x, it's minus sine x. And you can see from this graph also that this portion, the slope is what, positive or negative?
Negative.
Negative. And sine curve is positive, right? The
Yes, sir.
value of sine. But the value of minus sine is negative.
Uh,
That's why
yes.
the derivative of cos is minus sine.
Yes.
So at this point, the slope is 0. So minus sine is also 0. So you understand the relation by as a derivative. So the interpretation of derivatives is slope of the curve. dy by dx is slope of the curve y equal to f of x. Okay.
Yes, sir.
That is the geometrical interpretation of derivative. So this result we got from first principle, no? Derivative of sin x is cos x. Similarly, if you put cos x and do this expansion, you will get this result. Derivative of cos x is minus sin x. Exactly the same way. Here you have sin c minus sin d, right? We will get cos c minus cos d. Cos c minus cos d is 2 cos cos.
Yes, sir.
Sorry, 2 sin sin. Cos c plus cos d is 2 cos cos. Cos c minus cos d is 2 sin sin.
Okay, sir.
If you do it carefully, you'll get it. Uh, okay. Now we have two functions. Previously had one function, right? F. Now we have two functions, u of x and v of x. Okay. Now we have to find derivative of this product, okay, u and v. That we can do by finding derivative of v and u individually. So this is u into derivative of v. Short form of derivative is dash. d by d,
Yes.
d by dx of u, I can represent in short form as u dash. Okay. So this is u into derivative of v plus v into derivative of u. So this is called product rule. Product rule of derivatives. So similarly, you have derivative of u by v. That is v into u prime minus sign will come. Plus u into v prime divided by v square. So if this is called product rule, what is the bottom one called? They call the first one product rule. What could be the bottom one called? Which rule?
Quotient.
Yes. The spelling current quotient? I don't think so.
Yes, sir.
I is there?
Yes, sir. Is there?
Right. So this is basically derivative. See, y equal to f of x relates x and y. Okay. Derivative relates how fast y is changing when x is changing. Get the idea, no?
Yes, sir.
Derivative is when I give a change to input, how much output is changing. You can think the function as a system with input and output, where input is x and output is y. So when you change the input by delta x, how much the output is changing. Some function delta x if it changes by 1, delta y might shoot up to 1000. But some function delta y is 0.01. So that nature is captured by this idea of derivative.
Yes, sir.
Right. So now you know differentiation. So d by dx of tan x is secant square x. Okay. D by dx of tan x is secant square x. That you can get from the first principles. See, this way of arriving at the derivative is called first principles. Because we are using the first principle that d by dx is delta y by delta x in the limit delta x tends to 0. That's what we're using here, no?
Yes, sir.
That way of solving the problem is called by first principles. That you can do for tan x, but there is another way of doing getting the derivative of tan x. That is by using the quotient rule. Can you try? Let us take this function. You try on a paper. I'm also trying. Y equal to tan x, which is equal to sin x by what is denominator?
Cos x.
Right. So now we can use this UV rule. D by dx of v by u or u by v. Yes. U by v. U by v is v square and then u dash vu dash. V u dash minus u v dash. Okay. So use this result to get this dy by dx. Do it quickly. U is sin x, v is cos x.
So u dash I can just assume u dash as sine x
U
plus
dash is
x.
no. That is from first principle. No, you don't have to go there. Dash of sin x is cos x. Cos x dash is minus sin x. This we have proved
Oh
earlier.
yeah.
So do it quickly.
Okay, so v would be v is cos x, and u dash, which is sin x, would be cos square x
You can just write c square instead of cos square.
plus sin square x. So is it by v square or by u square? I
V square.
differentiate.
V,
V square, okay.
Yes.
By
One denominator, see in the denominator here v is there, no? So in the denominator here also v is there. That way you can remember.
sir, cos square x plus sine square x by cos square x.
Hold on, let me write it. So it is u sine into v dash. V dash is cos dash. So this is cos into sine prime is cos square. Cos square plus sine square divided by cos square. So it is 1 by cos square. 1 by cos square is secant square x. So this is the result. Derivative of tan x is secant square x.
Yes.
So here we have not used first principles. We have just used the quotient rule.
Yes.
So this is the result. So this is basically derivative. So you can get derivative of any function from the first principle or using already derived relations. Derivative of sin x is cos x, that's derived from the first principle earlier. So use this result here and use the quotient rule.
Yes, sir.
So, any questions?
No, not really.
Comments? This is part of maths for physics, basic maths.
So what do you refer to as lim?
Limit,
Oh, okay.
limit delta x tending to 0. This is an
Yes,
important
sir.
concept of limit. Tending to 0 means it is not 0. It is very, 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 very close to 0. That's why you can cancel h by h. Okay, if it is 0, you
So
cannot
it's
cancel.
so it's practically infinity. Anything divided by delta is infinity.
Yeah, very large, tending to infinity. Rather than saying infinity, say tending to infinity. Okay,
Yes.
so this concept was given by Newton. This is the basic idea of calculus. Okay, today is May 15th. Today will be the last day of my class. Okay, from tomorrow I am taking class only for 11th and 12th. Okay, so if you are interested,
So
you can join it. Uh, the class will be at
so
11:30. Huh?
in the morning, 11:30 in the morning.
Yeah, and if you are understanding that class, I will charge you. If you are not understanding, it's free for you.
Yes, sir.
Get the point?
Yes, sir.
Okay, because I don't want to charge you if you're not understanding. Okay, so I'll give an invite 11:30 in the morning. So you join. You can leave anytime.
So when will class begin again?
11:30.
No, sir. Sir, you said that today class ends. So when will class begin?
See, I'm not going to do that because see, initially I thought I'll handle this foundation and everything, 11th and 12th, but now it's becoming too hectic for me. So I'm realizing it's becoming difficult. So I'll focus on 11th and 12th only. So that,
Oh, okay, sir.
but whatever we're discussing right now is 11th portion only. Uh, so you are able to follow. So I think you can try attending that. You can leave.